All right, thank you. Yeah, I'm excited that this is our first online presentation for the group. We'll see how it goes. So actually, I do want to touch on the Web Almanac first, since you mentioned it. Especially to this group, you'll be interested in the performance chapter. I authored it last year, but I'm going to be passing it off. I don't want to be the canonical performance author for the Web Almanac. So I really encourage anybody from the web community, especially if you're interested in web performance, to contribute either as a co-author or as a reviewer or anything. This is an annual project on the state of the web as a whole, and focusing on performance is really important. And that actually flows nicely into the topic for this talk, which is core web vitals. And I'll switch over to my presentation now. So for a second, you're all going to see yourselves, but I will switch over. Okay. So I did tweet out this link. This is just a public GitHub repository called Presentations. You can find it. You can follow along if you'd like. So Core Web Vitals are Google's metrics that represent how users experience the web. We've, going back many years, maybe when New York Web Performance Meetup Group just started, we were looking at metrics like onload or DOM content loaded. And over time, we've understood that these metrics are not necessarily representative of the user experience. Just because an onload might be fast doesn't mean the application is fast. The example I give sometimes is like Gmail, where you load the page and then all of a sudden you'll see a loading spinner or something, but you won't necessarily have your inbox ready yet. That might have a fast onload time, but all the asynchronous stuff that happens after that is really what the user cares about. So the whole goal of having Core Web Vitals is measuring what matters to users. And we do that in 3 different ways. So in addition to the successor to onload, we've gone from onload to first paint, or also known as like render time or first render, first contentful paint, first meaningful paint. And now what we're settled on now is largest contentful paint. This is approximately the largest text or image in the viewport. One interesting thing about this metric is that it updates over time. There's not a definitive start time, or sorry, a definitive end time until the user actually interacts with the page. So there is this notion of an observation window with some of these Core Web Vitals. You'll notice here also that the LCP has good, needs improvement, and poor ratings. These thresholds are an indication to you as developers whether your users are having good experiences or not. You might think that these thresholds are kind of arbitrary, but there's actually like real science behind them, having to do with user behavior research and also studying the web and how achievable it actually is to have good LCP and other Core Web Vital experiences. So I'll get into that in a little bit, but I just wanted to get to the rest of these Core Web Vitals. In addition to the loading pillar, we also have interactivity or responsiveness. So as you're clicking on a page, maybe you want to interact with it and click a button, and I'm sure everybody has had that experience where nothing actually happens. So this is a measure of the delay of your first input. It doesn't necessarily represent all of the inputs and all of their delays, just the first one. This is typically when the page is still loading, there's still a lot of JavaScript to be downloaded, parsed, and executed, and the main thread of the browser could be pretty busy doing all of these initial setup steps. So the first input is often the one that suffers the worst. So this is an especially important one to measure. One important note about this metric is that it does exclude the time of actually handling the input event. So if I click on a button that loads a bunch of data asynchronously, it doesn't wait for that data to be downloaded and then appear something on screen to the user. This is just the delay of time that the browser is not able to start handling that event. The budget here is 100 milliseconds, which you might recognize from like old Nielsen research on how instantaneous things feel to people. Not even web users, but just people in general have a certain threshold of perception. Maybe 1 second, you start to kind of like lose focus, or after 10 seconds, you change tasks entirely. The third pillar for Core Web Vitals is cumulative layout shift. This is a relatively new metric. We haven't really had APIs on the web for measuring layout stability. But it's a problem that has been around for a long time, as long as pages have been slow to load. If you've ever been on a page and an ad loads in and then shifts the content down, and then all of a sudden you accidentally click on the ad, or you accidentally add something to your shopping cart or something like that. These are poor user experiences that haven't necessarily been able to be measured. So having the ability to measure that, in this case with a cumulative metric like CLS, has been really important to rounding out the holistic user experience. CLS, what the cumulative part of this means is each time one of those layout shifts happen, we accumulate that value. We just sum them up into this CLS. So you can imagine as you continue maybe scrolling through an infinite scrolling page, or just interacting with a normal web page, and things are changing dynamically, the CLS value will get updated. This raises some interesting questions. For example, when is the right time to report on my CLS if it continuously updates? We've had lab tools that have stopped. I mentioned the observation window earlier. Lab tools might stop measuring once the network is quiet. For example, Web Page Test does this, Lighthouse does this. So when is the right time to stop measuring things like cumulative layout shift? How do we measure an interactivity metric like FID in the lab where there isn't necessarily a user clicking on things? So these bring new challenges to the web, and especially in how we test web performance. I also want to call out, for each of these Core Web Vital metrics, we have links out here for optimizing each of them. What I'll cover in this talk are mostly the measurement and monitoring of the MOM acronym, Measure, Optimize, Monitor. If you're interested in how to actually improve your metrics, then these are some really helpful guides. The term Core Web Vitals implies that there are Web Vitals that are not core. So what exactly is it that makes them core? Google has committed to including these metrics, LCP, FID, and CLS, on all of the web developer tools that we offer, including Chrome User Experience Report, Pagespeed Insights, Search Console, Lighthouse. And we believe that these metrics are core because they're applicable to all web pages. From my time at YouTube, the metric that we cared about most was, when did the video start playing? That wasn't necessarily a metric that's applicable to all web pages. So we still encourage you to measure what matters for your particular applications, but this is kind of the common baseline across all websites that ensure a good user experience. They're all measured using standardized web APIs. CLS is based on the new Layout and Stability API, LCP based on element timing and stuff. So we want to make sure that people can measure these things without having to do any magic. And collectively, these are all representative of the user experience. The reason why we don't include something like first contentful paint as opposed to largest contentful paint is because we believe largest more closely resembles how the user feels that the page has loaded, whether it be quickly or not. The other thing here is these metrics are refreshed annually. We've heard a lot of feedback from the developer community about acronym fatigue, for example, CLS, FID, LCP, FCP. So we are committed to not changing these things more frequently than on an annual basis. That goes for the metrics themselves, but also the thresholds that we set. So you're not chasing moving targets. We give you advance notice when things are changing, and we give you the tools and resources to understand how to measure and improve them. And maybe most famously for Core Web Vitals, and maybe what you're all here to listen to, is about the recent announcement from Google Search about page experience being a ranking signal. Core Web Vitals make up a significant part of that signal. I can click in and show you what that looks like. So Core Web Vitals are just one part of the page experience signal. In addition, there's mobile friendliness, HTTPS, not having intrusive interstitials or ads. So these core web vitals are measured in the field. These are real user experiences as measured by the Chrome User Experience Report. So what I want to focus on in this talk are the ways that you can use the Chrome User Experience Report to understand how you're performing in your core web vitals. I did touch on how the thresholds are determined. I highly encourage you to read this. It's a research-driven blog post going into the two different factors of how we determined, for example, 0.1 to be the cumulative layout shift threshold. It's based on ensuring that there's a high quality of experience. So if experiences are below that threshold, then you can reasonably say that the user had a good experience, but also that it's realistically achievable. We don't want to necessarily say a CLS of 0 is perfect, so therefore everybody needs to have a 0. That's not realistic. The other thing is a single user experience could be below that threshold. Then you can easily say this was a good experience. But it gets a little more complicated when you have a distribution of many user experiences. For example, if you're looking at a single URL or an origin as a whole or a website as a whole. So for that, we recommend looking at the 75th percentile. A lot of you are probably used to looking at things like medians. And medians are fine. Medians are great. It's better than averages. But what's great about the 75th is that it's more inclusive of more user experiences. Obviously, 99th percentile is inclusive of a lot, but 75 is a nice balance between ensuring that it's encompassing most user experiences while also trying to ignore all the craziness that happens in the tail of web performance. There's a lot of outliers that can happen, a lot of edge cases. So if you want to say that your web page meets the expectations of core web vitals, all three of these metrics need to be considered good. So your LCP needs to be below the 2.5 second threshold. Your FID needs to be below 100 millisecond threshold at the 75th percentile, and your CLS 75th percentile needs to be below 0.1. You may be also wondering, I kind of go off in tangent, so bear with me, but you might also be wondering why there are no units for CLS, and that's because there are none, interestingly. So a layout shift is not, it's very close to, but not exactly the percent of the viewport that changed. That's why I kind of simplify it here to the proportion of the viewport. But as you continue to add up these shift scores, you want to make sure that you're below 0.1. All right. So we just covered what are we measuring. Now let's cover how do we measure it.
Rick, can I ask a question?
Absolutely.
So for the three core metrics, how ubiquitous is the browser community adopting these three metrics other than Chrome?
That's a great question. So these are web standards. So we would hope that across all modern browsers, they would adopt these standards. And then any user experiences that happen in those browsers would be supported.
Okay. All right, thanks.
Sure. I'd encourage everybody to check out this resource on web.dev. We have the developers.google.com documentation. Over time, we're going to be making that more of the source of truth about how things are implemented, but the how to use type of information and documentation will be included on web.dev in the future. So this link here will contain the branching off point for you to learn about all of these different tools that Crux is surfaced in. The first one is Pagespeed Insights. Anytime somebody wants to understand how they're performing in the field, I would encourage you to check out Pagespeed Insights. That's with the caveat that if you have your own real user monitoring or RUM or field data solution, definitely use that as the source of truth of how users are experiencing your site. The Chrome User Experience Report, maybe obviously, is only including user experiences from the Chrome browser. We found that it correlates very closely with what developers see in their first-party RUM analytics. But what's really nice about the Chrome User Experience Report is that it includes millions of websites. So if you have a popular website and it's public on the web, then you can reasonably assume that your website will be included in this data set, which lends itself to some very interesting use cases. For example, competitive analysis. You can see not only how your website is performing, but how your competitors are. We could also aggregate websites that are similar together. For example, all of the WordPress websites how do they compare against all the Drupal websites? And here on Pagespeed Insights, you don't have to be the site owner to see how a site or URL performs in the field. And we see that here in this field data section. The core web vitals are annotated with this blue ribbon. The numbers that you see next to each metric are the 75th percentile, and these bars represent the good, needs improvement, and poor distribution. I'll show you how that looks in the wild. This will be a kind of hands-on. That's why I'm not doing slides, so I can click in and show you how everything works. Pagespeed Insights is broken down by desktop and mobile. Mobile in this case is phone form factors. You'll notice later on in, for example, the Crux BigQuery dataset, we also drill down by phone and tablet. So when it says field data here, this is talking about the specific page we're testing. So the slash at the end signifies that we're looking at the root or home page. The origin summary shows how all pages on this origin perform as a whole. So all of those secondary pages, even including the home page, are bundled up and aggregated, and you can see how the overall distribution looks. Most of these are pretty similar. LCP trends a little bit worse, so that's interesting. So you'll see here that it has a pass-fail assessment for core web vitals, and it says it does not pass because 1 out of the 3 is failing. It's the 75th percentile, 3.4 seconds is greater than that threshold that we talked about, 2.5 seconds. So PSI is pretty straightforward. It's a daily aggregation. It's really useful because you can visit every day and you can see new results. One thing that might kind of complicate the real-time aspect of it is that it's a 28-day aggregation. You're not getting what was my user experience like yesterday. It's what was it like from yesterday to 28 days before yesterday. But it's still very useful. You could see your pass-fail assessment for core web vitals at a glance. And if you're failing that assessment, then you can be pretty sure that you wouldn't be meeting the page experience signal for search.
But Rick, is it 28 day? It compares against 28 days ago, or an aggregate of all of the past 28 days?
The window is 28 days wide, but it shifts by 1 day every day.
Gotcha.
And that's actually true for all of the, well, let me preface that. The 28-day window is true for all Chrome user experience support datasets and derivative tools. As you'll see here, the Crux dashboard is a 28-day aggregation, but the window shifts by 1 month every single time. So you can see June versus May, for example. That loss of granularity actually gives us the ability to analyze origins as a whole. Instead of having to look up a particular URL or origin, as you do in Pagespeed Insights, you can say, well, give me all of the origins, or you can run analysis and say, like, what % of origins are meeting the core web vitals thresholds. So what you lose in some ways, you gain in others. Here's a useful guide. I can show you what that looks like for using the Chrome UX Support Dashboard, or Crux Dashboard for short. This is what it looks like. You can, I'll actually have an example in a second, so I'll show you there. The dashboard includes more than just the core web vitals. There are also web vital metrics. These are kind of more loosely defined, but you can think of them as the diagnostics for how to improve or understand your core web vitals. For example, your first contentful paint and also your time to first byte are pretty much blockers to having a good largest contentful paint. So those are good metrics to keep an eye on. You can't have a largest contentful paint that's good if your time to first byte is over 2.5 seconds, for example. The other superpower of the Crux dashboard is that you can track changes over time. It's a month-to-month aggregation, so you can actually see over time how is my performance changing, whereas PSI is really just a point in time, the most recent snapshot of performance. I'll go through briefly. Whoops, that's not working. So the link for this is g.co/chromeux-. I'll fix this link. And so this is how you set up a Crux dashboard for yourself. If you're a first-time Data Studio user, you might have some permission prompts to click through, but in the general case, this is how it'll look. You enter a URL or origin in this case, HTTPS, say web.dev. I always recommend clicking this box. This means that once you've generated your report, you're able to also change which origins you're looking at dynamically in your Data Studio report. The next thing you do is connect and allow. Might actually be better if I make this narrower. Is this clear for everyone? And
Yes.
the next thing we do is create report. So now what Data Studio is doing is fetching from BigQuery the user experience data from the Chrome UX report BigQuery dataset. And it's generating all of these visualizations for you. So all you have to do is plug in the website you're interested in, and it'll do the rest. This is similar to a Google Doc, so you can share it with people. You can email reports. You can print it. You can do lots of really cool things. You can embed it in other websites. And I'll go to view. This is the landing page, the Core Web Vitals report. It gives you the most recent data sets comparison by device type, just for desktop and phone in this case. So you can see, actually, there is a disparity on web.dev between desktop and phone experiences for LCP. And the other pages here, one interesting one, time to first byte. This also surfaces the 75th percentile. Since the data in BigQuery is a histogram, it's kind of coarse aggregations of bins. So we have 100 millisecond precision here. In other tools, you might see millisecond precision. One other really cool thing is you can, for example, look at the device distribution of an origin. So this is 40% phone, 60% desktop, and see how that changes over time. One thing that's really interesting, web.dev is Google's web developer resource. And in November, we had Chrome Dev Summit. And I wonder if people at Chrome Dev Summit were visiting web.dev from their phone, and that created this difference in distributions. I think of this tool as something that's not only useful for site owners, but many people in this audience might also be performance consultants. You can imagine that if you're trying to win over a client, you don't necessarily have access to their Google Analytics data or their RUM data, but you can actually create a Crux dashboard of their website and see how they're performing from real users in the field. And maybe even more compelling, you can create a competitive analysis dashboard. I want to show you, I've created one already. I wonder if I can do it here. So this is exactly the same dashboard that I was just showing you. I took some time to edit this to include multiple quote competitors. These are not real competitors. And looking at their 75th percentile of, in this case, CLS, we can change that to FID and compare 75th percentile FIDs, hopefully. There we go. And see how those change over time. The way I was able to do this, I kind of had to augment the data sources in here. So the Chrome UX report data source that comes built into the Crux dashboard is limited to only one origin at a time. But in this case, you can plug in any BigQuery data source that you want. So here I connected it to, I wrote this custom query where I pull out using the materialized data set. We'll get into this in a second, the BigQuery data set. But you can pull out the raw data. You can graph it however you'd like. And you can include things like this in the Crux dashboard. One other thing, live demos are kind of risky, but I'll just show you here quickly. I might need a little more horizontal real estate for this. So let's say we wanted to compare two different websites, web.dev and developers.google.com. what we could do is maybe shrink that down, copy it, just to keep track. We'll label this web.dev, copy paste to that. Developers.google.com. So how do we change this copy to be developers.google.com? And we could do that here using the parameters. So by checking that box as the first step, allow parameters to be changed, you'll have this field in your dashboard, and you can easily just change that to something else. And now you have a side-by-side comparison of two different origins. This isn't very obvious to people who might just be starting off with the dashboard, but the ability does exist. All right, I want to move on now to BigQuery. This is what I covered in the web.dev live presentation. And I thought it'd be useful if I gave you a walkthrough of that presentation here and showing you where you can start out using those queries. On the Chrome User Experience Support GitHub repository, we have an SQL directory. So everything under there we just call the Crux Cookbook. So these are recipes you can use. These are tried and true methods for common types of queries you might want to have. And I have a subdirectory here just for mastering Crux. And these are numbered based on increasing complexity. So we'll start out just with this basic one. This will get you the core web vitals. And I have BigQuery open in this tab. By the way, you can access the BigQuery dataset by clicking this link. So we'll start off just by pasting that in. I'll make this a little bigger. All right, so the results tell us that the percent of good LCP experiences for web.dev is about 84%. And just to make sure, I think we can be able to verify this. LCP, oh, this is just for desktop, but so the percent of good LCP experiences, the percent of good fit experiences, and the percent of good CLS experiences, as well as their 75th percentiles. Oh, this is, okay, this is why. So this is for April. We can change that to June. You might be wondering, what about July? It's July already. So these data sets are monthly updates, 28-day aggregations. So the July data set is actually still being collected now. And at the end of the month, it'll start to become available. But the data set does not get published until the second Tuesday of the following month. So that's kind of complicated. I'll say it again. For example, yesterday was the second Tuesday of July. So yesterday we published the June 2020 data set. All right, so this is nice. So we can, for a single origin, see how its core web vitals are performing. The next thing in the cookbook is to get a time series of this. So how do we do that? Instead of limiting it to a certain date, let's try, let's see first what the fields are available here. Year, month, so that corresponds to the release, 4Ys. Want to sort by it. It's descending so we can see the information. Let's remove that and see what happens. So you hear that this process is 9 gigabytes. People who are used to running BigQuery queries might be a little jaded because of the expense required. The nice thing about this materialized data set is that it's pre-computing these fast and 75th percentiles for you. You're not going to have to do this on your own. We do have those underlying queries in the cookbook if you want to run them, but it's not necessary here. So these results are saying in June, the percent of good LCP 76, before that 84, 84, 85. So it has been trending down-ish a little bit. Yeah, you can especially see that in the 75th percentile, 1800, 1900, 2400. So that's been going up. One thing, as we're looking at this data, I want to make a note about interpretation of field data. it's very hard and very complicated to explain why certain changes might have happened. The conclusion I think a lot of people jump to is the website got slower. It's the simplest explanation, but it's more complicated than that. The user experiences themselves have changed. And as we know from field data, there's an enormous amount of combinations of factors that could be contributing to slow or fast performance, whether you're on a desktop or a phone, whether you're on Wi-Fi or 2G or offline or your geographic location. There's so many different factors that can affect whether the experience was fast. So we don't know necessarily that the website got faster, but all we can say is that user experience got faster or slower in this case. There was a really good blog post by Chris Zacharias from YouTube, and he was talking about the Feather experiment. And I really love Feather because it's a stripped down version of YouTube where you don't have all the bloated components on the page like the related videos and stuff. It focused only on delivering fast video. And when he ran that experiment, he found out that despite being a faster website objectively, it was actually slower in the field. And the reason he found was people from slower demographics started using that page more because it provided a better experience than the slow default experience. So you might see different shifts in user experience behavior, not necessarily explained by the website itself. So that's why it's so important to look at field data and understand what's happening. You almost have to be social scientists to understand what holidays are happening across the world. Oh, students are home from school, so they're using their desktop computers today. So things peak on the weekends, things like that. All right, moving on to the next query, device breakdown. You'll notice we're using here the metrics summary. There's also a device summary table. And this device summary table is also grouped not only by the date and the origin, but the device. So this is desktop, phone, tablet. So we can also add a new column here for the device. And we can add some conditions where the device is limited to only a couple of useful things to us. Tablet isn't very interesting. Nobody seems to be using tablet, but we have that data anyway. But for the purpose of looking at these results, we'll limit to desktop and phone. And we'll also make sure that we're sorting by device. This runs. So it only took about a second to query and to consume 2 GB. On web.dev, the desktop experience in June was 54% good LCP, 22% good phone experiences. So we can definitely see that phones are experiencing higher load times, which makes sense. Phones are more likely to be on congested networks or something, or smaller screens, worse CPUs. So there's a whole multitude of reasons. And finally, the other example here is country. This is something that's really interesting. I haven't fully seen this explored using Crux data. There are a few third-party tools that are starting to do this, and it's really exciting to see that. The third summary table that we have here, well, you can also see origin summary. This is kind of just a basic list of all the origins, so it's not performance related. But the third one, in addition to metrics, device, we have country. And I'll show you how to use that. If you've seen the presentation from WebDev Live, you'll notice that we have to, it's not actually partitioned by date, but partitioned by year month. Actually, in this case, we're not going to have to run it. It's not required, but just something to know. By the way, you can see how the table is partitioned in the details. 400 million rows, 100 GB, and it's partitioned by this year month field. The year month is the aggregation month, so June 2020, for example. Let's include from UX report. This is an experimental function called get country. We pass it the country code. Country code is a two-character descriptor for the country. You can take a peek at the data here to see what I mean by that. AE, AO, AR, AF. I believe AF is Afghanistan. So we can map those 2-digit codes back to the full country name. Call it country. And let's limit country codes Korea and Nigeria. I found these to be very different user experiences. They're good for demonstrating how important it is to look at geography and web performance. So desktop experiences among users in Korea, 82% good LCP, 30% good LCP for the same group in Nigeria. Twice as slow, 75th percentile LCP, just for example. So it's really super helpful to be able to plot the results this way. I also want to just show off. It's super easy also to export this data to a Google Sheet. You can plot this on a map almost. I mean, you can see how long it takes me to do this here. So let's create a pivot table. Let's just look at the last one. I'll create a chart. And that's no fun. Let's actually see it on a map. There we go. So here's a color-coded difference of, oh, that's funny. This is, okay, so it thinks higher is better, but we can actually swap that if we want. You can see visually here the difference. There we go. So that's just a quick way to visualize the data. So that's BigQuery. It's really a power user tool. It's very powerful. You have the full histograms at your disposal. If you have questions, if you're not as comfortable with SQL, I definitely encourage you to take a look at the Crux cookbook. There's tons of recipes there. But also we have a Google group just for Chrome user experience support or Chrome UX support, where you can ask questions about how to query things. We also have a tag on Stack Overflow, Chrome UX support, where you can ask any questions about the data set. How do I fix this query, for example? And the Chrome UX support Twitter handle is a good place to ask questions about the data set. Okay, so that's looking at Pagespeed Insights, Crux Dashboard, Crux BigQuery. And now we're going to transition into something a little more advanced, the Crux Api. You could query this API and get immediately, pretty much no latency, it's really fast, the user experience data for a given origin or URL. Pretty much whatever you can get on Pagespeed Insights, you can also get on the Crux API. So similarly, you can get daily aggregations of 28 days, aggregation window, 75th percentile is in there, LCP FID, CLS in addition, FCP is in there. And you can also drill down into desktop, phone, and tablet. There's unlimited quota, not unlimited. So you're limited by the amount of QPS, but you'll never be charged for using this API. It's really helpful. The easiest way I could show you, if I had my terminal screen shared, I can run this, but the easiest thing to do is go into this API Explorer and just hit execute. So it's already preset in the URL to look up the web.dev origin. And scrolling through here, we already got UX data. 82% CLS is less than 0.1. FCP, 75th percentile FCP. All right, so if you wanted to, let's say, narrow that down to desktop experiences, that's how you would do that. It's just a JSON object that gets passed in as the request object. The response will also echo back the request object, so you can just get visual confirmation. One thing is if you, let's say, add a slash to the origin, it will normalize that for you. It will remove that slash to make it clear that you're looking up the origin as a whole, not just the homepage of the website. And at the bottom, you should see normalization details. So you entered slash, but we removed that and we normalized it. This URL here is a super helpful guide I helped to co-author about using the API. There's tons of examples in here and shows you also this script, Crux Api util. This is a little JavaScript utility. It's a function that you can call called query. I have an example set up here for you. So this is exactly the same. I've passed in my API key somewhere else so that you can't see it. And I'll just hit it and log the results. So you can imagine from any sort of web application, you can integrate your core Web Vitals data. So this opens up a lot of interesting possibilities. I'm a huge fan of Google Sheets, if you can't tell already. So one thing I've done is use AppScript, actually inspired long ago by Andy Davies' web page test script that he integrated with Google Sheets. I've been fascinated with that. So ever since then, I've built everything in Sheets and using AppScript. So on a daily trigger, what I've done here is set up a ping to the Crux API, and I'm saving the data here. So this way I can get daily historical records for a given URL or origin. And we can have a dashboard-like interface on top of that where we just pivot on this data and also plot it in a sheet. So how does this work? It's all based on this GS. It's pretty much JavaScript, but it's Google AppScript. And you're probably wondering, okay, well, this is nice, but how do I use it? So also in the Chrome UX Report repository adjacent to the Crux Cookbook, SQL queries, we also have GS, where you can find how to use the Crux API. And using this script, you would just substitute out your own URLs. You can make a copy of this sheet, which is also linked in the GitHub repo that I'm presenting from, and you can just monitor whatever matters to you most. I do want to note that on a daily basis, you might see certain URLs come in and out of the data set. That's totally normal. It's based on a popularity threshold. So some days you might not have enough page views to be included in the data set. We don't give out that number of where that threshold is. We don't want to say too much about how popular websites are. But rest assured that if your site is small to medium size, you should be included in the data set. All right, what other cool things can I show you?
Hey, Rick.
Yes.
About that threshold, that's something I've been wondering about because, like my normal monthly views are between 250,000 and 400,000. And most of the time when I run the Crux report, it says not enough data collected. That just seems kind of odd based on what you just said, I guess.
Mm-hmm. I would encourage you to create a thread on the Crux forum, the Google group, and we can investigate that further. Because a lot of the times these things are based on like individual URL structures or weird things like that. So we can help investigate that. Okay. Make sure there's no bugs on our end, especially.
Well, it's more about me trying to understand what's going on because I get numbers, but I just, if someone asks me about it, like a client asking me about it, I want to be able to kind of explain, what they're actually seeing rather than inferring kind of thing. So,
yeah, it's a good question. I think one way to demo this problem, it might be related to your question here. I'm passing in a URL for desktop, and the moment I try to say like parameter foo, let's see what happens. Data not found. So the Crux API, I'm not sure which tool you're using, but the Crux API in this case looks up URLs verbatim. So you need to make sure that the URL matches whatever users are seeing in production. Yeah,
I actually just dropped. When you were talking, I just dropped in my main homepage there, and I still got the little message at the top, and I was like, this seems kind of odd. So
okay, you're getting this not found error.
Well, not in the BigQuery, but actually against the like Pagespeed Insights to Crux report thing. That's what I was. That's generally what like customers are going to look at. They're not going to go into this view so much. That's
sure.
A little too technical. So
yeah, the API really is the developer interface on which they build other applications that maybe other stakeholders can look at.
Right.
So it's important for developers to understand like what the underlying API shape is.
Mhm.
I see it's 6 o'clock, so I'll start wrapping up. Search Console is the last tool. I wanted to show you what that actually looks like in practice. So here is the Web Almanac's website's Core Web Vitals report. Thankfully, we don't have any poor experiences here. It splits it by mobile and desktop. I'll zoom in here. Let's say the desktop. There are no poor experiences, or these are actually grouped by URL. So there are no URLs with poor experiences. All 45 of our pages are considered good. One really cool thing is that this report groups URLs based on similar experiences. So the HTTP2 page or chapter is the representative page of all 45 of these URLs, since as the website, most pages are built on the same templates. So it's not very helpful for me as a site owner or as a developer to see like the HTTP2 chapter needs to be worked on, the performance chapter needs to be worked on, this and that. It's just helpful to say the chapter pages need to be worked on. So grouping pages like this is actually a really useful way. And I haven't actually seen this a lot in RUM tools, but I'm really interested to see it take further hold in the industry as well. You could see individual URLs if needed, and then you can click into Pagespeed Insights and you can analyze this page and see your performance there as well. All right. So I think, yes, 1 minute over. So that's all I got. I'm happy to take any questions. And I'm also mindful that we have another presenter coming up after this, so we can have time for that as well. Thank you, everyone.
Thank you, Rick. Thank you, Rick. It was awesome. So when was the API released? When was that available?
The API release, I forget the day, but it was last month. There's a date here. June 25.
I have a question.
Sure.
So from what I understand, the data that is available to you depends on whatever you own the website that you're looking at. At least Chrome, Webmaster Tools and Chrome, which is called Search Console these days,
Yes.
is like gets you more information than public data set. Can you talk about that really, or maybe I'm wrong here?
No, you're right. So the public tools like the BigQuery dataset, the Crux Dashboard, you could query the dataset and say, give me all the origins that are fast or slow, and it'll return a list of origins. We don't include URLs in the Crux dataset on BigQuery. Now on Pagespeed Insights, we're using the Crux API. You can say for a given URL or a given origin, what is the performance like? But you need to know, you need to provide as input those URLs. This is different from Search Console. So because you're authenticated as the site owner, you can say, give me all of the URLs on my website that's known to Google search and show me how they perform with Core Web Vitals. So that's one of the superpowers of that. And that's a good incentive for people to use that tool because it gives you a little more granular insights.
Thank you.
Mm-hmm.
That was a great question, and that's what I wanted to follow up on for Search Console. So the data is based on Crux, but if you are the owner, you can see individual URLs on top of the aggregate data.
That's right.
Correct?
Yes.
Oh, but you only have access if you are the owner.
That's right.
Not. Okay, perfect.
Yeah.
Thank you.
I'm the only one who can click this link and see results. If anybody else did this, you'd probably be prompted to log in. But you can see individual URLs and how they perform. It would be nice to have a, I mean, it's a blessing and a curse that I have a website that's all good URLs. It would be nice to show you some poor ones too.
Oh, I think everyone can log into theirs and see pretty well. It's unusual to have everything to be at the green.
Yes.
Great job optimizing it. This is what we do at Meet for Speed meetups. So, sorry, shameless plug here.
I have to give a lot of the credit to Barry. He's our tech lead on Web Almanac. He is our performance and accessibility champion and internationalization and everything. He's done a lot of hard work on this. So shout out to Barry. Any other questions? All right, thank you, everyone.
Well, thank you very much, Rick. This was awesome. I'm happy we're recording it. We have another presenter who is also going to talk about Web Dev Live, and a big part of that was progressive web apps. This is Michael Solati, who is also a big supporter of GDGNYC. And he will do a demo even how we can create a progressive web app and what's the latest. Michael?
Hi there, guys. Give me a second. This is the first meetup I've done on Google Meet, so just a moment. All right, I am assuming everyone is able to see a screen that says PWA, right?
Yep, you're good.
Yes, we can see.
Awesome. Okay, so as kind of mentioned before, my name is Michael Solati. I am a developer program engineer at Google, which means I mostly do engineering stuff, and actually the product or service at Google that I spend most of my time on is actually web.dev. So I was happy to see for the most part, everything looked good on web.dev. But I, developer program engineer on web.dev, I happen to love the web. I grew up with the web. I remember how the web used to be in the 90s, the 2000s. And now in our modern web environment, I think it's amazing, compelling, exciting. And we have these really incredible tools to make amazing and compelling experiences for others. I have a Mass product. Just for those of you who don't know, Mass is memes as a service. So if you guys are interested in sending memes to your friends, this is a hard pitch for a side gig. Go to memegram.com. That's the end of the pitch. And I will wrap this up by saying I have made a lot of mistakes. So I'm hoping that maybe I can share some things, things that I've had to learn painfully about developing progressive web applications that you can learn from me and not have to make the same mistakes I did. So simple question. What exactly is a progressive web app? And the answer is that's not right. A progressive web application is not that. You can really think of a PWA as just web applications that have amazing experiences. And the simple reason for that is because they're fast. They respond quickly to users, whether it's loading or responding to user interactions. They're integrated. They show up on a home screen, and they have access to sensors, GPS, and can do things like handle push notifications. They're reliable so that they load instantly, and they never show the dinosaur that we saw just as previous screen. And finally, they're engaging. They feel like a natural application on a user's device, and they're able to provide an immersive user experience. So why are PWAs so important and a thing that we should be striving to build towards? It's because users spend most of their time on native applications rather than websites. Apps are more predictable. They're available immediately on the user's home screen, and they support push notifications that are able to re-engage a user back into the application. And so though native applications are used more than web applications on mobile, that home screen space that a native application provides ends up being really, really valuable, because only about 70% of the time a user spends on their phone is between their 3 favorite applications. So even with that in case, like we need to be able to try to be just as compelling of an experience, because we're fighting for a commitment for time and space on a user's device. On average, a user installs 0 new websites or 0 new applications on a monthly basis. But they're likely to visit a website more often than install an application. So there's this weird balancing act between wanting to be on the home screen just because we're more likely to be engaged, but it's difficult to get on the home screen. So why PWAs? PWAs are essentially these web applications that provide a near native experience on mobile devices. And so they're able to start quickly, work in the background. They're able to work offline. They have access to sensors, different versions for different platforms. And web apps have great reach. You have one site that is able to work on every platform. It can be safer, but with all these things in mind, we need to introduce the features of native applications to the web. So this little video I have here, I'm just going to play it, and I guess I'll try to talk through it or over it. But this is a Twitter app I have installed on my phone. Things load in. I'm able to scroll through the Twitter app fairly comfortably and easily, compose a new tweet. I have access to my camera roll, so I can attach a photo and add it to my tweet. But the big catch, or the diff between this and with this application is that this is actually just a web application running on my device. The experience is virtually identical to the experience that you get from the Twitter native application. But there's one major difference, I think, that's of note. And this was something weird when I was tinkering with the Twitter PWA versus the Twitter native app for Android. When I looked at the installed apps on my home screen, the installed apps on my device, I noticed that both of them, with all the cache files and everything, they both said 250, 250. And I thought that was weird that they were like the same file size. Then I just looked, because I wasn't really paying attention. I looked at how it was being measured, like megabytes versus kilobytes. And I noticed that the native app installed on my device was taking 250 megabytes compared to the progressive web application, which was taking 250 kilobytes. For virtually the same experience at a fraction of the storage size, I made a hard switch to the PWA for Twitter because it provided virtually the same experience at a fraction of the cost. And I've stuck with that since. So taking a sample PWA that I've thrown together, I have this app called Popular Movies. It's fairly simple. It just showcases movies. And if you click into a movie, you can view more details. It kind of looks a bit like maybe a Android tablet application, just because I'm following this material design guidelines using material components. And under the hood, it's just running Angular. And just to see how well this performs as a progressive web application, I can run some tests against it. And so I'm going to just let these tests run for a few seconds. All right. And so the end result doesn't seem too good. Looking at it in a lot of cases, it's not really being understood or classified as a PWA because it's failing to be fast and reliable, installable, and it's not really optimized. And there's a slew of important reasons why this is the case, though I will say these are all things that, as a developer, we can easily resolve with just the use of a service worker and a few other tweaks to our application. But the key takeaways from the web application as it stood then was that it was not fast, it was not integrated, it was not reliable, and arguably it was not engaging. So one thing that I did, I used a tool called Lighthouse. For those of you who don't know what Lighthouse is, it's an open source automated tool for improving the quality of web pages. And that was the tool I actually used to run tests against the web application that I had for showing movies to get feedback as to what areas that the web application was lacking. So you can run Lighthouse against any web page, whether it's a public page or if it requires authentication. And it has audits for performance, accessibility, how it fits as a progressive web app, and more. And so Lighthouse is available inside of the Chrome DevTools. You can actually also install it as a Chrome extension, and I believe there is a extension for Firefox as well. And finally, you can just install Lighthouse via npm. So you can use it as a command line tool or just include it in some of your node scripts, maybe as a test in your build process as well. So taking the basic web application that we saw just a few moments ago, let's try to make it a little bit better. And the first thing that we can do is that we can make this application more reliable. That means there should be really no surprises. That's the sort of thing we want to avoid, surprises. So when launched from a user's home screen, our service worker will enable a PWA to load instantly, regardless of whether the device is connected to the internet or not. And the service worker it's written in JavaScript, and it's much like a client-side proxy that puts you in control of the device's cache and how to respond to resource requests. So you can pre-cache key resources and therefore eliminate the dependency of the network to load some of these resources or assets. And this can ensure an instant and reliable experience for your users. An example of how that could work is this picture we have here. This is a caching first example, which is ideal if you're building an offline first user experience. This is how you can handle a majority of requests. And there are other strategies you can apply, but just introducing a service worker to your site can be super easy where we have this process. So in this example, we have the page makes a request. It goes to the service worker. First, it checks the cache. If the asset or resource is in the cache, it will return it to the page. If not, then we'll go check the network. Then the network will return it to the page, and the service worker will cache that asset or resource for future use. So if you're an Angular developer, you can implement a service worker super easily by just running the command ng-add@Angular PWA. It'll add the Angular service worker to your project. It enables the service worker in the CLI build process. And it does a bunch of other things, but it's just as simple as that for adding a service worker support to your Angular application. If you're a React developer, well, at I/O 2017, we announced that Create React App actually includes service worker and PWA support up from the get-go. So if you're a React developer, just by using Create React App, you have service worker support. As well as Vue. And the Vue CLI, it's super easy to enable a service worker from the get-go. So when you go to create a new Vue application, you can manually select some features. And the feature that you want to just install is the progressive web app support. Once you do that, you can let the default settings go for the rest of it. So this will customize and configure everything you need for your Vue application to be able to use a service worker. And you can make a few modifications as well based on what you need. Now, in regards to both the Vue and the React progressive web application support, they both use a tool called Workbox. And this is just a tool to help you more easily build a service, to use service workers. So if you aren't using any specific framework, or if you aren't using these CLI tools that make it easier, I definitely suggest using Workbox, as it's an agnostic solution to implementing a service worker. You can think of it as a library that bakes in a set of best practices and removes a lot of the boilerplating that you as a developer have to write when working with service workers. It really helps with addressing things like pre-caching, runtime cache, various strategies, request routing, background sync. It provides some really helpful debugging, and it provides a greater flexibility and feature set than some other tools. So Workbox is available via NPM, and there's actually a really great article that we host on web.dev in regards to implementing and using Workbox to build service workers. So just as a quick thing, I would recommend hitting up web.dev/Workbox and just look into that if you want to have a better understanding about service workers and how Workbox works. So with that, our application is more reliable because the application is able to run offline, and it's a little bit faster as well. But we can get even faster. And this is important because the average load time of mobile websites is around 19 seconds on a 3G connection. So that's kind of a long time. And while we live in a great environment where we have easy access to 4G, 5G connections, that's not really the standard. And our service worker is able to address some of these concerns after the first load, but we can address that slow load times by optimizing our initial load, parse, compute, and rendering of our web applications. And this all ties into this massive concern, and that's really in regards to the cost of JavaScript. So I am stealing this slide from another member of the Chrome team, Adi Osmani. And so keep in mind, if we want it to be fast at JavaScript, you have to remember that it has to be downloaded, parsed, compiled, and executed quickly. But not all bytes weigh the same. A 200 kilobyte JavaScript file has a very different set of costs than a 200 kilobyte JPEG file. And this is outside of the raw network transmission times for both sets of bytes. They might take the same amount of time to download, but when it comes to processing, we're dealing with very, very different costs. A JPEG image needs to be decoded, rasterized, and painted onto the screen, versus a JavaScript bundle, which needs to be downloaded, parsed, compiled, executed. And there are actually a number of other steps that an engine needs to complete. So just be aware, the cost of the file size aren't necessarily equivalent. Remember, the JavaScript being sent down the wire has to be rendered and computed and rendered out. And this takes time. But we can take this burden off of the user as well as the user's devices and put that burden onto our servers by using server-side rendering. Luckily, all the major frameworks actually have decent support. And as a front-end developer who doesn't want to write a full back-end solution, it's super easy. But if you don't want to use these tools, or if you're looking for a framework agnostic solution, you can actually use Puppeteer. Puppeteer is a node library which provides you high-level access to Chrome DevTools protocols. It runs headless by default, but you can configure it to run non-headless. And you can actually do a lot with it. One of the most important features that we can use is to actually render out all the JavaScript for a single page application or SPA and send the rendered out HTML to the user. So like Workbox, you can install Puppeteer via npm. And this is actually just a really simple implementation in order to handle server-side rendering of a JavaScript web page using Puppeteer. And so you can just send that HTML straight to the user. So with that, our application is reliable because it works offline. It's faster because assets are cached offline, as well as the first time a user visits the page, they already get the rendered out HTML. They don't need to wait for the JavaScript to be downloaded, parsed, and executed. The final thing is wanting our applications to be a bit more engaging and to feel like a natural application on the user's device with an immersive user experience. So PWAs are installable and they live on a user's home screen without the need for an app store. They offer these immersive full screen experiences with the help of something called the Web App Manifest and can re-engage a user with push notifications. For the Web App Manifest, I would say this is actually one of the easiest things to implement. There's these simple tools that make it really easy to create that manifest file to generate icons for all different screen sizes. So if you are interested in generating the Web App Manifest file and just dump that into your project right away, visit this URL. It makes it super, super easy. It'll give you a bundle that you can download with the Web App Manifest and all the image icons. And all you really need to do is go to the index.html file of your web application. And these are really the only two lines you need to add. The first is pointing to the manifest file, and the second is the theme color. That theme color being just like if you visit a website on Chrome, on Android, you'll sometimes see that the address bar will change color to kind of match the theme of the website. These are the only two settings you really need to set. And with that, you've turned a kind of plain just web application into a progressive web application that is fast, integrated, reliable, and engaging. And so, yeah, if we ran the Lighthouse test with implementing all these things, we'd have green across the board. If you're interested in the web application for the movies, you can visit it at pwa.auto.dev. And in the top right corner, there's a GitHub icon. You could click on that to view the source code for this project. The slide deck, if you want to look at it, is available at bit.ly/building PWAs. And finally, I really want the key takeaway is that however fun of a game the Chromosaur might be to play when you're offline, we want to build experiences where users are actually able to use our web applications without the need of the internet and to have still these compelling, good experiences. So the Chromosaur should go the way of the dinosaur, which is extinct. Anyway, my name is Michael. I'm available on the web on all these different platforms. And moving from here, I want to make sure I have enough time to actually work on a code lab that we host at the Google Developers website. Out of curiosity, and I invite you to just jump into the chat and respond, how many people have actually tried Codelab that Google has? I would say not all at once. You guys can take your time for this. Okay. Well, if you're interested, the Codelabs are available at codelabs.developers.google.com. It's pretty much a bunch of tutorials and hands-on coding experiences that we provide to kind of help you implement some of the things that we work on. So there's tools like TensorFlow, AR Core, different things with AMP that we actually have, and Android, which are different lessons that you can actually take to get a better understanding and experience these things. And there's one code lab I actually want us to work on, which I'm actually going to go through the code lab live. But if you guys want to follow along with the code lab, I actually have a place for you guys to go to do this. So if you guys go to bit.ly/WDL Codelab, you'll be taken to a glitch project. So I'll just keep this on the screen for a second, and I will drop it in the chat. And then I'm actually going to walk through the code lab, and I invite you guys to do the code lab with me. And if you guys have any questions, you know what? I just realized a bunch of you people said that you have tried the code lab, and I just did not scroll down in the chat. So I'm sorry that I completely missed that. Hold on a second. And actually, Chris, I see. Yeah, Chris, I'm seeing some of the things that you responded about, kind of just breezing through it and not really addressing some of the nitty-gritty stuff. Not intending to be misleading as much as just trying to quickly go over the stuff. Otherwise, this would have been a little bit longer, and I wanted to get the chance to get to the actual code lab part. But you are right. I am definitely breezing over things that are kind of important. Okay, so if you guys visit the URL that I just shared, let me just give this a little refresh. Okay, so what I'm going to do real quick is I am just going to, got to keep this open. So there's this thing here called Getting Started. Follow the Google Codelab instructions. I invite you guys to click on that as well, only because these are going to be the directions I'm going to follow for the Codelab, but we're going to be doing it all on Glitch rather than on my on a local device. And so once you guys have that open up in another tab, I invite you guys to just remix the project. So just click on the project name, then click Remix Project, which is just going to fork the project for us. So the point of this code lab is in order for you to learn how to use Workbox and IndexDB together to make an offline first data-driven PWA. It also uses background sync, so the app can sync to the server even when the application is closed. So if you actually look at the Codelab instructions, it discusses that you'll learn how to cache an app shell with Workbox, how to use IndexDB, retrieving and storing data, syncing data. It has a few expectations as to what you should already know, but we're just going to work from here. So if you've remixed the project, you should have all the code necessary. And also, guys, at any point, if you guys want to jump in, I invite you to just leave a comment in the chat or just speak up. Please feel free to speak up. So we're going to work on this Codelab, and we're going to jump into step number 4, just because everything is pretty much set up already. So step number 4 has us go into our app folder and into the sw.js file. And this is where we're going to start to define some of our service worker stuff. So the first line I'm going to bring in is this import command. So import script, it's going to import this Workbox SW file. I will admit import script is something I did not know about for a while, but this is pretty much allows web workers to pull resources from different, just to pull JavaScript files in and execute those. So this will import Workbox and make it available in the service worker that we're going to write here. And so we're just going to do the simple check. If Workbox is defined, it says it's not defined, but it will be defined once it's executed. It'll console log Workbox is loaded, and then it'll run this little pre-cache bit which we'll define later. And if Workbox isn't available, it'll run it'll console log, boo, Workbox did not load. So with that, now that we kind of have a very, very simple service worker bit defined here, we're going to want to, and I'm just going to actually follow through the Codelab also. So this is all defined. OK, so the next thing that we're going to want to do is build a production version of the service worker. So that's the next bit. So the recommended approach to pre-caching your project files is to use one of the Workbox build modules, such as Workbox build, to generate the list of files to pre-cache. So we're going to create a gulp task called service worker that's going to generate our pre-cache manifest. And we're going to add some code to the project, to the gulp file JS file. So let's go to gulp file JS, and we are going to add this task, and I'm going to add a task right here. So here's a task that we're creating. The function is called service worker, and so it's going to generate a manifest file for with Workbox. It's going to follow some of these things. So it's defining which files we want to cache. Then we're defining this function as a gulp task. So there's the gulp task service worker, which is going to execute service worker. And the final thing we are going to, there's two things we need to do. Right now, Workbox isn't necessarily defined in our gulp file, so we're going to come up into the top, and we are going to define or import Workbox build. Actually, I'm going to just copy this to make sure I do this correctly. Right on the top of the file, we're going to require Workbox build in order to have this actually work. And finally, we want to have the service worker task actually execute. So we're going to include it in our build process that we're going to also build the service worker. And the build is actually the default when gulp runs. So when we run our gulp file, it's going to run. When we run our gulp file, it's going to run build. And build is a series of gulp tasks called, which are clean, copy, and service worker. So if I save all of that, that should be good. So we are building out our service worker now. So the final thing we need to do is actually register the service worker when a user visits the page. So I'm going to go into our app, JavaScript, and main.js. And so we're going to add the service worker registration code to the top of this file. Here, right there. Save that. And this should be enough to actually see it. So let's preview the application. We'll do this next to the code and let this start up. All right, here's the application. I'm actually going to do it in a different window, only because I realized might be some problems. Also, again, if you guys have questions, please feel free to jump in. I am kind of zooming through this for time's sake, but I do want to be able to address questions or concerns people may have as we work through this. So we're going to allow notifications here. Okay. So here's the application right now. And if I go to inspect and go to the console, we should see that yay service workbox is loaded, which means that this code is executed, which registers our service worker, which is defined over here. So yay, workbox is loaded. Okay, so that is step 4 of the project. And we can jump to step 5 of the Codelab. And I'm actually going to bring up these steps here also so you guys can kind of see what's going on. So let's go to the next step. So at this point, the app actually isn't storing any data in the browser, and it can't actually display data when the user is offline. And let's actually see if that's the case. So if I go to network, set this to offline, give this a refresh. Yeah, so we have no actual event data, but we want this to be able to display event data when we're offline. So let's work on that next. So we're going to add the following function to the main.js. And this is Createindexdb, which is going to create an IndexDB database. So we can go into our main JavaScript file, and we'll just add this right at the top. So this will create an IndexDB instance that we can use. We actually have to call it though. So we'll add this DB promise, which is going to be a created instance of IndexDB. And let's see what it says here. Okay. So we'll save this file. In the above code, we created a dashboard or database and given it a version number 1 inside the upgrade callback function, which is what IndexDB uses to modify. All right, so this should allow, let's see how this works now. Let's go online again. Give it a refresh. Let's see if we throw this offline again, what ends up happening. All right, nothing yet, but I think that's expected for the time being. We're just creating the database, but we're really not doing anything with it at the moment. So let's go into the next step, which step 6 is actually to save the data into the database. So we're going to add a function to main.js, which saves event data locally. It'll take the events and looks like it'll add it one by one. So we'll throw this next function on top, save events data locally. It'll check if IndexDB is in the window. If it's not in the window, it won't do anything. But if IndexDB does exist, then we'll get the database and then we'll write into it every event that we pass into the event. So here's store put the event. All right. So what we want to do is we're going to modify this load content network first function. And so we're going to be, let's find that load content first function. Here we go. And finally, we're going to make another change to this add and post event function, which let's find the add and post event function. OK, so what do we do here? So the save event data locally function takes an array of objects and adds each object to the IndexDB database. The store put operation happens inside of a promise all. This way, if any of the put operations fails, we can catch the error and abort the transaction. Aborting the transaction rolls back all the changes that happen in the transaction so that if any of the events fail to put, none of them will be added to the object store. In the load content network first, once the server data is received, IndexDB and the page are updated. Then when the data is successfully saved, a timestamp is stored and the user is notified that the data is available for offline use. And finally, the call to save event data locally in add and post events keeps the local data up to date when the user adds new events. OK, so this is making sure that information actually gets saved to IndexDB, but we're not yet calling the information from IndexDB. So we'll go to the next step, step number 7. And now we want to actually retrieve the information. So we're going to have this new function that we're adding called getLocalEventsData. So let's add that again to the top. And so what we're doing here is first, again, checking if IndexDB is in the window. If it is in the window, then we are going to go to the DB and get all the events and return the events for that. So I think that looks right there. So if that's going to read the information for us, we're going to update our load content network first. Before we had it so it saves event data, but we're still going to update it so it reads event data. So let's update that function there. And so now if there is no network availability when load content network first is called, then the get server data function rejects and the catch method takes over. And the catch, here's our catch, we call get local events data function and retrieve local events. So what we're doing here is first we're trying to get from the network. If the network ends up failing, it looks like, then we're going to try to get the data from our local cache. All right. Catch method takes over, retrieves the local data from IndexDB. If there isn't any local data saved, then the user is alerted by message no data. Otherwise, the local data is displayed on the page and update UI. OK. So this should be saved. Let's quickly update the application. And let's one more refresh just in case. Let's throw this offline and see what ends up happening. So now if I refresh, that did not quite work. And I think this is just because an old service worker data is here. So I'm just going to quickly clean something out, and then this should hopefully work. So give me just 1 second. Yeah. OK, so now we have our updated web application with the service worker that's going to save data to the local database and will pull from the local database if we don't have a connection. So we have 1, 2, 3, 4, 5, 6, 7, 8, 10 events. We're going to create a new event. I will call this web.dev 5 NYC. Today, NYC. We'll add the event. Here's our event here. And if we let's set the application to offline, give it a refresh. I messed up somewhere. Yeah, I'm not sure where. Give me a second. OK. Give me a second just to figure out what I broke, and then we can go from there.
Looks like you have a console error of some kind, and it complains.
Yeah,
network.
the console error was expected only because it's this get all fetch. Though I'm not 100% sure why that get all fetch was failing. I will admit running it on glitch can be a little funky. So if I check console, yeah, so it says endpoint get all. That's the failure point. I'm gonna quickly look over to see if there's something. So I think it's happening here in this get local events data. Debugger would make sense, but I'm just gonna see if this is the get all that fails for the store. Okay, so Workbox is loaded. It doesn't try to pull events locally, which I think this only gets called if the network fails. So what I'm going to do here is I'm just going to throw an error. So me throwing an error inside of this then statement will force the catch. Let's see what happens. This should. Let me clear out the old service worker. Skip waiting. Make sure this is updated. And okay, I think this old service worker was just being cached and it was throwing errors, which unfortunately can be an issue when developing around that. So I will get rid of that catch condition, or get rid of the forced error. Update the service worker on reload. And let's try to give this a refresh and see what happens. Okay, so here we have server data was stored. We have web.live NYC. I'm going to mark it as offline, give it a refresh. And the events still load, but now because it's offline, it's giving the error message, or a message up here saying that it's offline. Web.dev live NYC is still here. We'll create a new event. Add that. Put it online again. Gordon, Gordon, you just asked, is IDB a global? Yeah. I actually have to look at the code. I think in this case it is. I think we define IDB is defined here in this closure. It's like just one of these things that's already created. So there's IDB promise.js. So it doesn't. It's not inherent to the window. It's just something that's been created for the use of this. So you see IDB promise is imported before main.js. So it's brought into the global scope from this script and is available in main.js. If I just switch the order for this, this would break, absolutely break. Hopefully that answers your question there. So give this a refresh. New events isn't synced, and that's because we didn't do the background sync function. But I don't necessarily want to go over. I know I'm a little bit under. Would you guys want to go to the using Workbox background sync so we can ensure that events added offline will actually get synced when we go online again? Or if you guys want to just ask like different questions, because I know I've just been like ranting and raving for a little bit about how to do this Codelab, I would totally be down to do questions as well. Chris, needs to be as global if you create an IDB. You know what? I very well might be wrong then, but the use. So Chris just said IndexDB is a global. If you create an IDB variable that is set to the library being used, then it would be a global level within the service worker. So that is something I was mistaken on. I apologize. The next question is, do you polyfill background sync for iOS Safari? That's a great question. I would actually have to go through the Codelab to that next step in order to find out. Though I don't.
Well, the reason why I'm asking is because you know, iOS Safari, well, Safari in general is the bottleneck for everything right now.
Yeah.
Yeah, so that's why I was wondering, because you know, I've had a few customers ask me about background sync with you know, obviously with iPhone scenarios, and you know, right now Chrome and Edge are really the only browser supporting background sync, and so that's kind of the deal. I mean, I've got workarounds that I put in place, but it's not, you know, automatically native in the background like it is in Chrome and Edge. So plus the background sync API is pretty complicated, in my opinion anyway. So
no, you're probably right in that case. And I know I mean, there's been just a lot of issues for iOS actually supporting service workers in its full capacity, though I don't know how Workbox actually addresses that. That would be a question I could look into. Though in this Codelab, I don't think it necessarily gets into the nitty-gritty differences between background sync for iOS or Safari for iOS specifically. So unfortunately, I don't know for that.
I do have another question. For the and somewhat related to what Chris originally mentioned about the CLI tools not necessarily highlighting what's included in PWA support, right? Like he was saying that PWA is a big umbrella term, which sometimes is making it hard to understand what's included in particular implementation, and what when conversations happen in the business context, it's very hard to understand what is being expected versus what needs to be implemented, right? Just too high level, great term, just high level, right? Do you know any resources that help kind of highlight all of the features that are included in the term PWA, and maybe highlight some support, and maybe highlight kind of what's required versus not? For example, service worker is kind of required, right? While notification support is an optional feature, or whatever, right?
Yeah. So the it might be 3 to 5 things. I will figure out how many things it is as I list them off the top of my head. The first thing that I would say is an absolute necessity. So the end goal, one of the end goals is that for PWA support is for Chrome to suggest a user to be able to install the application onto their device. If you've done that, you've hit the minimum threshold to be a PWA in the sense of a browser. In my opinion, that's really not enough. The things that you really want is, first, the service worker enabled, just so the application is able to work in some capacity offline. Full functionality offline, I don't think is a necessity. A great example of this, I think, is dev.2, where it is a PWA. It does work offline, but what it tells you is, hey, you're not connected to the internet. This application doesn't work. But if you want, here's a pad that you can draw on to kill time. The app doesn't necessarily work offline, but you don't see the chromosaur and things just fail to work. Like it offboards you on the fact that the experience isn't going to be the best in a much better way. Or in some cases, you want some functionality of your application to still work. Maybe if it's a social media network like Twitter or Instagram, maybe you can at least see the feed up until the last time you viewed it. So you want something to work instead of the chromosaur. The next thing to hit that threshold to be available on a user's home screen is the web app manifest. This actually defines what the experience feels like when the application is added to a user's home screen. And if PWAs are supposed to bridge the gap between web applications and native applications, you want to be able to define that in a way that makes your application feel like a native application. So the service worker, something working offline, as well as the web app manifest. I would say the final most important thing in my mind is some form of server-side rendering. It helps improve the speed and the perceived speed of the application, because native apps, unless it's like a bad native app, kind of feels snappy and instantaneous. So you want to be able to address that, because an issue with most like JavaScript driven applications is that first you see a white page and then the JavaScript renders out all the components. If you can at least have the first page load almost instantaneously, that's awesome. And another reason that that could be beneficial is, let's say if the user is offline and maybe some assets you haven't actually cached aren't there to be rendered. If a rendered version of it's already cached, then that addresses that concern. The push notifications are cool. They're not necessary. So service workers, so something loads offline. Server-side rendering, so the first experience is snappy and then everything else falls back to JavaScript, is good. And the web app manifest, so the user can actually add it to their home screen. In my opinion, those would be the most important things for me to consider it like a PWA. So the next question I'm seeing is, what is a TWA and how are they different from PWAs? TWAs are trusted web activities. If you're familiar with Cordova or Ionic, pretty much what those things try to do is allow you to wrap a web application in a shell that can be run on devices that so it looks like a native app, like they can install it from the Play Store or App Store. What a trusted web activity is much the same thing. It just gives your web application a sandbox as an Android application. So then you could list your progressive web application in the Play Store. It's really just a wrapper in order to be able to install your app in the Play Store, much like Cordova was. Though Cordova gives you more functionality, trusted web activities are an easier way to do it. In fact, I think Microsoft and Google just released a tool that makes it like super, super easy to list your application as a trusted web app, TWA. Give me a second, because I can actually probably pull this up. Chromium Labs, it might be Google Chrome Lab.
So the TWA concept hasn't really been talked about a whole lot since I feel like since it was first announced a few years ago. I just posted in the chat. Is the real difference between that and say just the web APK that you get with the install, the actual install process for add to home screen? Do you actually get access to Android specific native APIs, whereas with the just installing from the browser as a web APK, you don't get that access? Is that really the main difference there?
So I'm not the expert in this category, in this area. So I apologize if I misrepresent something. I don't believe there's actually any massive, I don't think there's any change in access between what a PWA and TWA has, other than the wrapper for the Play Store. And this is me having tried to dig into it to figure out what the differences are. But on Android, at least I can say, a TWA gives you, just puts your application in this like Chrome or Chromium web view, much like just Chrome does. And so the Chrome team's focus is more about giving you access to some of these more native-like APIs. For example, on the security side of things or identity side of things, like something that isn't necessarily an Android API that you have readily available, but something that the Chrome browser wants to give to you is there's this, I think it might be an Origins trial, but it's a functionality where you can, and this sounds bad, where you can kind of read a user's text messages. It's not that you necessarily want to read the text messages, but let's say if you're a company that sends a two-factor authentication code via SMS, you could leverage Chrome on Android to look for that two-factor authentication code and autofill that for a user. That way, they don't have to fill that in themselves. It just auto-populates. That's not necessarily an Android API, but it's a Chrome for Android API that's made. It's something that the Chrome team is making to kind of bridge the gap between Android and Chrome, so you as a developer have more access to things that are natively expected. Another great example is having access to the contact list. So if you're, again, building something, let's say like a Twitter, on a user's device, you can request permission to their contacts. Browsers don't necessarily do this, but Android for Chrome does this because we're trying to bridge the gap of functionality between what a web app can do versus a native application. So I don't think TWAs necessarily add that, but TWAs leverage the things that Chrome is trying to implement. That was a bit of a ramble. I apologize. And as a quick aside, there's a library or repo on Google Chrome Labs called Bubble Wrap, which is supposed to make it super easy for you guys to turn your PWA into a TWA. That way you can list it in the Play Store. So I'm just going to keep this on the screen for now if you guys are interested in looking into that more. So I see Samar mentioned, she dropped a link in the chat for the SMS Retriever API, which is, I believe, what I was discussing. So I invite you guys to click on that in the chat as well. And I actually should just drop Bubble Wrap in the chat as well.
So, I get a lot of like stakeholder types connecting with me, trying to figure out stuff more about what is the, really a progressive web app. And to me, I feel like there's a lot of, misunderstanding about a lot of stuff because it feels like a lot of people don't think that APIs are actually accessible unless it's a progressive web app, which is not correct. For example, like doing the camera like we're doing here in the Hangout, right? A lot of people don't think the camera access is still available on the web. There's a lot of people still don't think geolocation is available, for example. And they think that progressive web app magically enables some of this stuff. I don't know if the Chrome team, how the Chrome team's been trying to adjust the messaging around it, because I haven't honestly seen a whole lot of noise the last year or so compared to what it was, say, 3 or 4 years ago, trying to define, what defines a PWA. And, I see developers kind of being, feeling, expressing similar kind of, expressions about that too. But I don't know if you can address, it can speak to where the Chrome team is about general messaging, especially to stakeholders about, the difference between, being a progressive web app or just taking advantage of the APIs that are available to the web in general.
Yeah, I can't necessarily speak for the Chrome team, and I don't necessarily want to speak for Google, but I will speak for my experience and what I've seen personally. I feel as if progressive web apps and this attempt at defining what a progressive web app was massive at least 2 years ago, even last year, though I think over the course of the past year, and I think what you'll continue to see is the priority is going to shift, not necessarily into users building PWAs per se, as much as they're building experiences that can compete with the native application. And in some cases, that means making tools available to developers. You're absolutely right. Things like geolocation, the SMS retriever, like even Bluetooth, they're not things that you need to build a PWA in order to have access to. And that's because like the definition for PWA is kind of this loose, broad thing. But they're things that kind of bridge the gap between the web and native. So the main goals, I think, is less about defining what a PWA is, as much as it's like driving developers to build experiences that are just as compelling or fast as a native application. But by doing it on the web, you have greater reach, because there's a lot of places where native applications aren't necessarily the best solution. There's some devices where native applications just stop working because the developers opted not to support an older version of Android or iOS. Though an application on the web can live forever. So that building a good experience there should be important. I don't know if I answered your question. Hopefully I kind of touched on what you were trying to ask. I'll take that as a maybe.
Well, I mean, I get it. I mean, it's difficult because people are, like I said, I have a lot of stakeholders coming to me about, possibly building a progressive web app for them because they really been told you can't do X on the web. Like I had a guy this weekend just challenging me that you can't actually play audio files on the web, and I'm just like, and I have this kind of hit me all the time, and it's just one of those things. I'm trying to like sell the concept to business people because that's who pays me, obviously, but at the same time trying to make sure that the messaging is correct. But I'm trying to find the right path, and I know y'all do a lot of more research than I've got the capability to do, and y'all do a much better job of kind of surfacing marketing terms, I would say. So, but at the same time, just what is that umbrella? Like you focused on what I would call the core features like service worker, manifest, kind of stuff, right? But to stakeholders, it's this massively broader umbrella of functionality, so to speak.
Yeah. Unfortunately, my area doesn't necessarily cover how that could actually work, but I think what would be really good, and we have a section on web.dev that we list all these case studies, which are examples of these like massive applications that run as web applications first. And I think something like really important to consider is like if you have stakeholders coming to you, like we don't expect that the web is capable of doing X, Y, and Z. In my opinion, a strong argument is like, well, like companies like Wells Fargo, they're able to do like their native application is really just a web application in a wrapper. That a lot of these major companies that are able to actually do a lot on the web. So I actually just went to web.dev/tags/case-study, where we have examples like for here on the Betty Crocker website with the Wakelock API. There's 300. I mean, there's different case studies here, but I think giving examples of how other big companies are using the web in compelling ways can showcase that, yes, no, the web is actually capable of doing this. And one big selling point is you only need one development team that's able to create an application or experience that's available to every user. Everyone has a web browser. It's not iOS, Android specific. It's not specific to anything. So you get the broadest reach for the least expense. And I think in my mindset, like the first thing you really want to do in order to get something off the ground is just like I would first build a compelling web experience. The web falls short in some places. For example, if you're doing a mapping application that actually has to render like a lot of geopoints, web is going to fall apart there. But that's more of an edge case for what an application is expected to do, in my mind. So I'd say the web is making the argument for look at these other experiences that are web driven. Is the strongest argument as to why web should be like trusted as a reliable place to build on for experiences. Like if you want to build a music player, Google's pushing YouTube Music for better or worse, but hey, the web app on desktop is actually really good. For better or worse, they're pushing that.
I installed it on my home screen for sure.
Actually, one thing that I just realized, a really good case study, and I don't know if we're going to I'd find it right away. I believe it was Hulu. Hulu discovered that their Android tablet application absolutely sucked. And then they ended up, I think it's Hulu, I could be completely misrepresenting this, but they ended up turning their desktop, their Android tablet into like a TWA thing. So it ends up just sharing the web experience, and they noticed a massive uptick in like positive sentiment on the app experience. it's a media streaming application, but I think that is a good example, like for a big company that did a web focus first. It was for tablets, it's not for mobile, but it was still running on Android, and that was like that had a lot of positive sentiment and feedback. Though I think I am maybe out of time. I'm just like pushing and rambling and responding, so I appreciate the questions.
Are there any other questions? No? Well, thank you, Michael. It's always great to do a code lab. We've done Firebase code labs. We've done AMP code labs, and now Progressive Web App. It's always good to have an interactive experience and a hands-on experience. And so thank you for your time, and thank you for everybody who joined. Please let us know what you would like to see. We're planning an Android 11 meetup to know the new features, probably in August. But I think that was fantastic web performance updates. And Sergey, I hope we do another joint meetup soon. It was all
we should
combine forces. We've been talking about it for a while.
Yeah, and we have a Meet for Speed next week, by the way. If anyone is interested, you feel free to sign up for that. Again, that is a hands-on, like, performance analysis / improvement conversation. So
Yes, I can attest to that. As a matter of fact, I submitted a site to be analyzed, and it was awesome advice. And actually, I would like to share one thing that's related. So Ralph and I started to help. I hope everybody can see the screen well. Ralph, the organizer for GDGNYC, and I started to help a foundation called Positive Planet. They're launching in the USA to help the underrepresented start a business and become entrepreneurs. It originates, the Positive Planet originates from France from 20 years ago. It has projects in Africa and the Middle East, and we're building the site. We are planning media, communication, PR events, and of course, digital marketing and performance. So if anyone wants to be involved, for the moment, the website, like I said, based on Sergey's analysis and his web group analysis, we started to building the web site from scratch, and we are very mindful of the performance, but it's an awesome initiative. So we're building the team. The head of the foundation is a Google Sales Cloud exec. Her name is Ingrid Gonzalez. She's great. And like I said, the goal is to have training and start fundraising and have activities in the US with New York, partnering with other organizations, but we plan GDGNYC to be a big part of it, have events for the entrepreneurs, different trainings, and we're building a site where people can donate, where they can understand what the projects are. So if anyone is interested, you can, I put my mobile phone and email. We'll drop my LinkedIn if you prefer that in the chat. But it's been super rewarding to work on this. I love it. So if anyone has any time, they can be part of the team as well. And I think that's all for now. Thank you very much. Yesterday we had a Flutter and Firebase And today, big thank you to Michael and to Rick to know about web performance. And I hope to see you all soon. Anything else to add, Sergey?
No, great to see you all. Thank you for coming. It's awesome. Let's make everything fast and everything.
Yes, no spinning, no
Yep.
spinners.
No spinners, only fast websites. Yes.
Cool.
Take care, everybody.
Bye for now. Yes.